The lesson objectives for today: identify linear functions and linear equations. And then you have to know how to graph linear functions that represent real-world situations and give their domain and range. Keywords from the objectives are identify linear functions and linear equations. And then you have to be able to graph linear functions and give their domain and range. F of x equals 2x plus 1 is a function. That means it's like a machine. If it were a vending machine, you would put the money in here, and then the answer would come out. Whatever you put in here for x, you insert for x in the actual expression, and then evaluate. It can also be written as y equals 2x plus 1. Y equals 2x plus 1 is the same thing as f of x equals 2x plus 1. When it's in this form, it's easy to graph because it's slope-intercept form. Y equals mx plus b, where b is the y-intercept and m is the slope. You can insert values into f of x equals 2x plus 1 in that place for x, just like we went over before. You can put any number in there for x. When you do that, you plug it in for x here and then evaluate. So if I put a 3 in for f of x equals 2x plus 1, I put the 3 here. That means I'm putting the 3 into the expression and then evaluating that. 2 times 3 and then plus 1, which is 6 plus 1. Gives me an answer of 7. I plugged in 3, I came back with 7. 3 was the x. What you get back is the y. It creates an ordered pair. Whatever you're putting in, the x values are the domain. Domain is going to be x. The range is going to be y. Domain x, range y. So as an ordered pair, we plugged in a 3, we came back with a 7. 3, 7 would be the result. X is 3, y is 7. That creates an ordered pair that you can put on a graph. Go over 3 and then up 7. Make a dot. If it's in an ordered pair form, the domain is 3, range is 7. X domain, y range. Okay, so here's an example, the actual example we have to get to. Each domain value is paired with exactly one range value. The graph forms a line. So all throughout here we have points x, y. When you plot them on a graph, create a line. X is domain, y is range. Now we can determine if this is a function or not. If it's a straight line like this, the answer would be yes. That is a function. Question is this a function? Yes or no? The answer is yes. If it's a straight line, it's a function. If you can draw a straight line vertically through that graph and it only touches one point, that line touches one point, this touches one point, and this touches just one point, then that would make it a function. That is the vertical line test. So look at this one. If I draw a straight line here, I touch one point. There, I touch one point. There, I touch one point. So is this a function, yes or no? Yes or no, is this a function? Yes, it is a function because we drew a straight line here and only touched one point. Here, 1 point. Here, 1 point. Anywhere I draw a straight line up and down, a vertical line is just going to touch 1 point. That means it is a function. However, is it linear? Yes or no? Does this form a straight line? No, it does not. So if the question is it linear? The answer is no, it does not form a straight line. Here's C. The only domain value, 3, is paired with many different range values. So that means if I put in a 3, I'm going to get back a 4, I could get back a 1, I could get back a 2, a -1, because I'm going over 3 and then up 1, 2, 3, 4, down 1, down 2, down 3, down 4. Whenever you have a bunch of ordered pairs and you have a case where you have an x value that's 3, and let's say you get back a 4, or you could get an x value that is 3 and you also get back a 1. If you have two x values that are the same, like these 3's, but your y values are different, this would not be a function. The answer would be no. Because if I draw a straight line up and down through here, look at all the points that I'm touching. It's touching more than one, it's touching all of them. Is this a straight line though? Is it linear? Yes. Okay, bring up the answer to this. Answer 2 questions. You'll write the word function, yes or no, and then you'll write the word linear, yes or no, beside it. You have 2 things to write. Write the word function, then put yes or no. Write the word linear, and then put yes or no beside that. For the function, is this a function, yes or no? I can draw a line vertically through this graph anywhere and only touch one spot on the red line. So the answer to the function question is yes. And then for the linear question, it is a straight line. So that one is yes as well. Is this a function, yes or no? I can draw a straight line vertically, and everywhere I draw it, I get 2 points. So the answer is no. Is it a straight line? Is it linear? Answer is no. You have a table of values. You have a -2, 7, -1, 4, 0, 1, 1, -2, and 2, -5. Notice that you have a -2 matched with a 7. Is there a -2 anywhere else in this table in the X column? A -2 anywhere else in the X column? No, there is not. So this is matched with this one only. Do you see any different values, or any that are the same, I should say, in the X column? Are any of those values the same? No, they are not. In the Y column, it will not matter if they're the same. So in order for this to be a function, in order for that to be a function, you would have to have all of these X values be different, as well as all of these matching up with only one X value. In other words, if I had a -1 here going to a 4, I couldn't have a -1 anywhere else in the X column and have it go to a different number than +4. So in this case, is this a function? Yes. And then linear, is this a linear function? Does it create a straight line? Well, look at your X values. They go up by the same amount. the difference between your x values is 1 each time. They're going up by 1. Look at the y values. They're going down by 3. They're doing the exact same thing each time you step downward or upward on the x value. These are doing the exact same operation. They're dropping by 3. If that's the case, then yes, it will be linear. Here's another one. You have -2, -1, 0, 1, and 2. These are going up by 1 each time. So we have all different x values, and they're consistently going up by 1. But now look at the y values. When you go from here to here, you're going down 3. But when you go from here to there, you're going down 1. And then from here to there, you go up 1. From 3 to 6, you go up 3. Is this a consistent change out here on the right for the y values? Are the y values changing consistently by the same amount? Yes or no? No, they are not. So in this case, we can say to the function question, yes, because each item here is paired one x value with one y value. There are no x values that point to two different y values. As far as linear goes, the y values are not increasing or decreasing by the same amount each time we increase the x value by the same amount. So the answer is no for linear. Is this a function? Yes or no? And is it linear? Yes or no? Same directions as the previous two practice problems. First, we'll see if this is a function. Yes or no? Well, we got to see why. We have a 2. Is there a 2 anywhere else in the x values in those ordered pairs? No. And here's the same thing in chart form. You have a 2, 5, and an 8. So that's okay. But now look at the y values. The y values are decreasing by 1 each time. If these are all going up by the same amount or down, and these are all going up or down by a consistent amount, then you can say that it is indeed linear, yes. And for the function, since we have all different x values, and they point to different y values, that the answer is yes for a function as well. Is this a function? Yes or no? Alright, so for function question, we have a -10 pointing to a 10.
Teachers, excuse the interruption, but at this time I need anyone in 8A, which is Mr. Dixon's homeroom, to please report to the gym for pictures.
You have a -10 pointing to a 10, a -5 pointing to a 4, a 0 pointing to a 2, and a 5 pointing to a 0. At no point in there do you have two x values that are the same pointing to two different y values. For example, if I had a -10 pointing to a 9, that would mean that this and this are the same, but they point to two different values. If that were the case, the answer would be no. But we don't have that in this case, so it is yes. That is a function. And as for the linear, the x values are increasing by 5 each time. But notice that for this, you're going down by 6, but then you go down by 2 and down by 2. Is this a consistent change in the y values? No, it is not. So the answer is no. Here's another practice. Tell whether the set of ordered pairs 3, 5, 5, 4, 7, 3, 9, 2, 11, 1 satisfies a linear function. Is this a linear function? In other words, the question is it linear and is it also a function? So you have two questions combined into one. It must be both. If the answer to both is yes, then you just write yes one time. Is this a linear function? Okay, so you have a 3, 5, and I'm looking at the x values. You have a 3, 5, 7, 9, and 11. They're all different, and they point to different numbers. So that's going to be a function. We know that much already. So function, yes. If you put these in terms of a table, such as 3, 5, 5, 4, 7, 3, 9, 2, 11, 1, and look at the change each time. You're going up by 2, up by 2, up by 2, and up by 2. And that's on the x's. For the y's, you're going down 1, down 1, down 1, and down 1. If your change here is consistent each time, as well as this change being consistent each time, then it would also be linear. So is it a linear function? The answer is yes. Slope-intercept form of the equation of a line. You have to understand this in order to be able to graph an equation. Slope-intercept form. This is the form, y equals mx plus b. M is the slope. Slope is rise over run. It means how far up and down you're going to go, and then how far to the right. Slope always goes to the right. The b is the y-intercept. That's where the line is going to cross the y-axis on the graph. The y-axis is the line that goes straight up and down through the center. Slope is m, y-intercept is b. Now you have to know the standard form of the equation of a line. The standard form looks like this. ax plus by equals c. You can interchange between slope-intercept and standard form. You can change equations to be in either form. So here's an example of a linear equation that can be written in standard form. 3x plus 2y equals 10. You can also rewrite it. You can make that this here is linear. This is an entirely different equation. This is a separate one. This is a different one here as well. This one is a linear equation, and it can be written in standard form. You would be moving this x over to this side, and then this to the other side. It would give you another form than what's listed here, but that is a linear equation. This is a linear equation. It can be written in standard form as well. All of these are linear. These are not linear, and you will have to differentiate between linear and nonlinear. You saw the linear equations where you have an x and a y that are in an equation, and they're separated by addition, subtraction. But look at this case. You have xy multiplied together, and then plus an x. That's not linear. You have an x cubed. An x cubed, anything with an exponent other than 1 is not going to be linear. And if you have a variable in the denominator, that's going to make the equation not linear, like 6 over y. None of these are linear equations. So here's an example. Tell whether the function is linear.
At this time, I need Mr. Kessler's homeroom, and Miss Edelman's homeroom to please report to the gym for pictures.
Tell whether the function is linear. If it is linear, then graph the function. So what we're looking at is this. Could somebody get the door? This will be a highlight reel for the number of interruptions in one classroom. I'm just letting it record so I can have something to remember this by. Here is the problem. It is y equals x plus 3. Is that linear? Well, notice that it's in this form. Y equals mx plus b, where the slope m is 1 and the y-intercept is positive 3. So yes, it is linear. In this example, they are changing it into standard form. So notice how they've done that. And I'll erase my writing and we'll go back and look. They're moving it into this form, ax plus by equals c. And to do that, they are moving this x over to this side, so they get minus x. But standard form is that the x term comes first and then the y term second. So you just switch them around. You put the negative x out front and then the y to the right of it. So it's negative x plus y. They've just reversed these terms. So negative x plus y equals 3. If you can put that into a standard form, that also lets you know that it is linear. And if you have to graph that, we'll copy it down here. In order to graph it, you want to refer back to this one, y equals x plus 3. So we'll come down here and put y equals x plus 3. To graph this equation, you would have to find the y-intercept first. The y-intercept is the point on the y-axis, notice this is y, where the line crosses. So you could make a dot there. And I'll put mine in blue. Then you use the slope. The slope is the number next to the x. What number is written immediately to the left of x? What number do you see between equals and x? It's always there if nothing is visible. It is 1, yes. And if you have a slope of 1, that is the same thing as 1 over 1. You can write any number over 1. That means that we have a rise of 1 and a run of 1. Not run. We have a run of 1. Therefore, from the point you just made, we will zoom in on it. Kind of blurry. But you would go up 1 and then to the right 1. The bottom number always goes to the right. You went up 1 to the right 1. And notice it just keeps going, up 1 over 1. Once you have 2 points plotted, you could have plotted one there and then made the line. That is how you graph a line from slope-intercept form. Remember that this was being put into standard form to see if it was linear. A lot of times you don't have to do that. You can look at it like this and tell if it is a linear function.